For the video today, we're going to take a look at writing equations of parallel lines and perpendicular lines. Just a couple of quick things to keep in mind. With parallel lines, you have to have slopes that are the same. So in order to create parallel lines, if one line has a slope of 2, the other line also has to have a slope of 2. And for perpendicular lines, you have to have opposite or negative reciprocal slopes. So to get started, we're just going to look at a couple of examples and then have you try a few on your own. So we're going to write the equation of a line that's passing through the point -1, 1 that is parallel to the line y equals 2x minus 3. So the first thing that we have to do is find the slope of the line that we're given. In this case, it has a slope of 2. So I'm just going to jot that down here. The slope of the slope of the line we're given is 2. The lines have to be parallel, so the slope of the new line also has to be 2. Now, the other thing that we know is that it has to go through a certain point. In this case, it has to go through the point -1, 1. So here's what I know. My new line has to have a slope of 2, and it has to go through the point -1, 1. Now, we can, at this point, use a couple of different formulas. We can use point slope, which is y minus y1 equals m times x minus x1. And at this point, I can plug in the slope and I can plug in my point. So I have y minus the y value of my point, which is 1. And that's going to equal the slope, which is 2. And then in parentheses, I have x minus the x value of my point, which is a -1. And minus a negative becomes a positive. Now it does say find the y-intercept by using the slope and the point. So at this point, if I want to get this equation into y equals mx plus b form, I can take that 1 and move it to the other side. But just a little reminder that this form is okay. You can leave it in point slope form, and that's perfectly acceptable. But if you want to, you can put it into slope intercept form. So I'm just going to move the 1 to the other side and distribute the 2. And so when I clean that up, I get y is equal to 2x plus 1. All right, so just really quickly up here, when I bring this 1 to the other side, I have to add it. And so then my y-intercept turns out to be a positive 3. All right, so that's choice number 1. That's your first option. Second option is to use y equals mx plus b. So I'm trying to fill in y equals mx plus b. Now, I know the slope of this new line has to be 2. And I also know a point on this line, and that point gives me an x value and a y value. The y value of my point is 1. The x value of my point is -1. And then what that does is it allows me to solve for b. So I have 1 equals -2 plus b. And if I add 2 to both sides, all right, so either way, the equation of this line is going to be y equals 2x plus 3. All right, so those are two completely separate ways of coming up with the equation. It's up to you which way you prefer. And then we can check it. We can graph to check. So on this one, I know that my original line had a y-intercept of 3 and a slope of 2. So I'm just going to graph that line really quickly. And so that line looks like this. And then I want to see if my new line is parallel to it. That has a y-intercept of positive 3 and a slope of 2. And so I can go ahead and I can graph that line and just double check and make sure that they actually are parallel and make sure that my line goes through the point -1, 1. All right, the next thing we're going to do is write the equation of a perpendicular line. So this time we're going to write the equation of a line that's passing through the point 2, 3 that is perpendicular to the line y equals -2x plus 2. So again, we have to find the slope of our original line, which is -2. And perpendicular lines have opposite reciprocal or negative reciprocal slopes. So if this line has a negative slope, my new line is going to have a positive slope. And if this line as a fraction is 2 over 1, my new line is going to have a slope of 1 over 2. All right, so those have to be opposite reciprocal slopes. Now, when you multiply these two things together, their product should equal -1. So if you're not sure if you came up with the right new slope, you could multiply -2 times +1/2 and see if you end up getting a -1. All right, so same thing that we did on the other problem. At this point, we know that we have a new line whose slope has to be 1/2, and it has to go through the point 2, 3. And so at this point, there's absolutely nothing different from what we did to find the equation of a parallel line. I tend to prefer point slope form, but if you like y equals mx plus b, if you like slope intercept form, feel free to go ahead and use that example for your notes. And then we can see at the end if we come up with the same equation. So the y value from my point is a 3, my slope is 1/2, and the x value of my point is a 2. Alright, so now it does say find the y-intercept. So what I'm going to do is clean this up, get it into slope-intercept form. So I need to add the 3 to the other side and distribute the 1/2. And so when I do that, I end up getting y equals 1/2 x plus 2. Alright, if you used slope-intercept form from the beginning, hopefully you came up with the same slope and the same y-intercept. And now we can graph to check and see if we're right. So my original line had a y-intercept of 2 and a slope of -2. And my new line has a y-intercept of 2 and a slope of 1/2. And so when I graph them, I can see that I do get perpendicular lines, which means that I came up with the right equation. All right, so the last thing that we put in our notebook was this writing equations with 4 practice examples. And so what I would like you to do is go through and see if you can come up with those 4. There are 4 examples, 2 where you're going to write the equation of parallel lines, and 2 where you're going to write the equation for perpendicular lines. So try those, come in with those done tomorrow, and then we can start looking at those at the beginning of class. So that's it for today.